Hi, everyone. Well, uh, let's start my talk. The title is Us-east-1 Shuffle, lateral movements and other creative steps that attackers take in AWS cloud environments and how to detect them. So, who am I? Well, my name is Felipe Esposito. I'm also known as Proteus, and a little bit more than 10 years of experience in IT security, mostly on researching and sysadmin stuff. I'm also a proudly father of a girl. I'm also a bulletin instructor, and my main job right now, I'm a security researcher at AT&T Security. And as a researcher, most of my job is googling around, reading documentations, and creating POCs and testing security stuff. But sometimes we are asked to help our clients with some questions they have. And I remember that day when I was reading docs, googling around, and one of our clients asked us, "Hey, can you take a look on these network diagrams and his IAM profiles?" And we said yes, yeah. And he was doing all kinds of nasty stuff. He was doing stuffs like VPC peering between prod and dev environment. He has cross account roles between almost all their accounts. And I say, well, no, you can't do like this because there's a thing called lateral movements, and an attacker can take advantage of it. And he was like, what? Yeah. So uh, I make this statement. I know it's a bold statement, but I have support. I have arguments to support this. So cloud security is more complex than on-premise security. So by the title of this talk, I was looking for uh, titles who might mean lateral movements, and the only thing that I could remember that moves laterally is caranguejo or CD, and or crabs in English. And I was like, not a good title for this talk. But my boss Sierra, he remembered this kind of dance is called Texas Shuffle, and it looks a little bit more like this. Seems fun, right? So, as I'm a Brazilian and I'm also from Rio de Janeiro, I had to bring up something different just to make a contrast between the Texas Shuffle and any other kind of dancing style. So, I brought you what we call funky, Brazilian funky, and it's something like this. Yeah, seems hard, huh? So, well, let's jump to cloud, but take those two dances in perspective. So when we talk about lateral movements on AWS, we, we can we can say things about like an attacker can move laterally between an instance on a VPC on account A and a VPC in account B if they have a VPC peering established between each other in routes and everything. And this is what we call the data plane. And if you take this in consideration, the data plane seems like on-premises network because we have network, subnetworks, hops between those networks, and the attacker can also move laterally between those networks on the data plane and also on-premises networks. But in cloud, we do have one thing that we call the control plane. And the control plane is basically how the AWS or other cloud providers control the data plane. So the control plane basically is all the APIs that we call for creating resources, deleting resources, changing properties on those resources, and things like that. So uh, And also in the control plane, that's where we have the IAM, and that's the thing that controls permissions on AWS. So what happened is you can have a role on the control plane, and you can assume another role on the same account. So if you have an account moderator, you can assume a role administrator on this account, and this is kind of a lateral movement. But we can also assume, we can also exec something on the EC2 instance that is on the same account. So you are in the control plane, and then you can jump to the data plane by executing a command on an EC2 instance in this VPC. But if that EC2 instance also has a role, you can also jump from between the data plane to the control plane by assuming this role. So things get a bit more complex, right? So, and you can also assume a role from the account A to account B. So you can assume another role in another account. And you can also assume a role from the VPC, the EC2 instance on the VPC A on another account, the account B, for example. And you can also execute any command from this role here on the account B to any instance on account on the VPC B. So this makes much more complex to understand lateral movement possibilities and much more complex to track this kind of lateral move possibilities. So I promised my sister-in-law, she's a dancing teacher, that we can't compare dancing styles, but we can compare aspects. So if you guys remember those two dances, which one of you seems more difficult to learn? The Brazilian funk is faster for sure, has a lot of fast movements, but he's dancing alone. And when you get Texas Shuffle, for instance, you have the interaction between the partners. You have to balance each other to understand where they are in the space. They have to coordinate this with the rhythm, and they can also dancing alone by themselves. Also, always looking for the other partner. So Texas Shuffle has some aspects that are more complex than Brazilian funk, right? So in order to illustrate how the attackers can take creative steps, I was wondering what can I bring to you guys? Would you remember this? And then I remember a music. It's called Cupid Shuffle. It's like to the left, to the left, to the right, now kick, now walk it by yourself, now walk it by yourself. Most of you guys might remember this. So it's like Macarena for Brazilians. Yeah. So we have some steps that are called to the left, and this happens between EC2 instance to EC2 instance in different accounts. For example, if they have VPC peering. So what happens is that ARP protocol doesn't work as expected on AWS. So in AWS, the ARP protocol doesn't have the broadcast. So there is no easy way to find what are the other networks that you have on the data plane. So you have to go to the default mode that's scanning. So yeah, you can use an nmap for scanning this. So you can scan a range /8. It's noise, but it's effective. And you can use this command right here to do it. And once you found another machine, you can, and after that, you can hack your way into this new instance and then jump in between EC2 instance also between accounts. There is another movement that are called step up and diagonal. That happens when you have an EC2 instance or a Lambda or ECS or a batch job, etc. Anything that can run any kind of a program, and that it has a role to assume. So there's also a MITRE tactics for this. The technique it's called 1550.001. And if the attacker lands for somehow any exploit or any vulnerability on an EC2 instance that has a role to it, he can assume a role and jump from the data plane to the control plane. So for this, so the attacker lands here, he can get a STS get caller identity to find out each role he has, and then he can just use the service that's called instance metadata. It's a service in AWS who allows him to get credentials, find out each IP address he has, and do a lot of stuff, find the host name and things like that. So with this service, he will be able to get the credentials as we saw right here. And with those credentials, he can jump to the control plane. And by jumping to the control plane, he would be able to use tools like Pacu. If you guys doesn't know, Pacu is like the Metasploit for AWS. So it's an open source AWS exploitation framework, pretty good. And it was developed by the guys of Rhino Security, especially by the late Spencer Gittin. So it's a great tool if you have AWS credentials to explore and to get doing more nasty stuff on the AWS. So another lateral movement, I call it step down, and that happens if any user with any user or role with SSCM or EC2 instance creating instance actions, and actions are kind of permissions on AWS, they can execute code and jump to the data plane. So if you have a user A who wants to jump to a specific VPC or a specific subnetwork, and this user has ability to execute anything like execute a EC2 instance that's already existing on this VPC, or if he can create an instance, he could create an instance on this VPC, execute code, and then jump from the control plane to the data plane. So this is a command that an attacker would do to make EC2 instance create a reverse shell for his IP address. So he's doing a AWS run shell script with these parameters, and this is what the EC2 instance will exec. So another movement that I call here, called to the right, and that is when you can assume role between accounts and cross accounts between AWS. So if you have an account A, you can do an account B has this policy. That means that any principal on account A can assume a role in account B. So if you have you can assume a role from account A to account B, right? But if you are in account B after assumed a role from account A, and you want to assume a role in account C, just jumping between accounts, you might think that the necessary thing to do is have this policy in account C, like any entity from account B can assume a role in account C. But the thing is, that's not true, because when you comes from account A, an attacker can assume the role in account B. He's not an instance of account B. He's an instance of account A. So this is not possible. The only thing that would be possible from assume a role from B to C would be a policy like this. So anything on B with assumed role and the name of the role and a value, because when you assume a role, you do a temporary value for this, like a comment for this assumed role, and this might also be true. But these kind of things, just to be honest with you guys, I never saw in production in any of our clients. So I don't believe it's feasible to find any other environment with this kind of assumed role, right? So this won't work for most of the things. But one thing that one attacker can do is jumping from the account B to a data plane and then assuming a role in account C. But this thing here, what we call assuming role for an account A and assuming role for an account C, it's called role chaining for AWS, and it also has a hard limit of 1 hour. So 1 hour might not seem a lot, but when we're talking about control plane, that things that has a lot of APIs really well documented from AWS, you can just script your attack, and 1 hour is enough time to run any kind of scripts. But yeah, this thing has a hard limit to 1 hour. But there's a bypass for that I call now kick and now kick. In that scenario, when you have account A with assumed role account B, and the account C has assumed role from account B, what an attacker can do is jump from the control plane to the data plane, gives TS2 instance the privilege to assume role, and as TS2 instance is an entity from account B, this policy in account C will work. And by doing this, this kind of movement, simplified here, the attacker can bypass this hard limit of 1 hour because EC2 instances, they're not treated as the same way the other instances are treated for assume role operations. So this is well documented here. And this bypass can work up to 12 hours. So what are the attacker requirements to do things like this? It has to have enough privileges, for example, STS assume role and resource star. He also must know related account ID. And for finding this related account ID, he can find this on CloudTrail, IAM policies, and also through OSINT. And they also need to know the origin of a role to assume the new account. So it can be brute forces, or if he came from the master account, if his account has a SSO single sign-on organizations, and if it came from the master, you'd be able to find another accounts pretty easily. So to have enough permissions, there's also a thing that we call AWS privilege escalations. And privilege escalations basically a set of actions that allows you as a principal to increase their privileges. So there was a great research by the late Spencer Gittin, also from Reno Security Labs. He found out around 28 no privilege escalations techniques, and will be a new one. It just released by Spooker Labs in his talk and Cloud Village. Watch it, don't miss it. And even more possibilities with the IAM pass role. And there's a research by Noah and Daham, where he's looking for IAM pass role possibilities and how to privilege escalation with them. But the thing is, privilege escalation is a thing in AWS, and that's not pretty easy to find out and understand those things. But not all privilege escalations are created equal, because not all techniques have the same effectiveness. And how so? So we have here two techniques. One, it's called create policy version. And if an attacker got a credentials, he has the not all actions on AWS, but he has a create policy version. He can create a new policy version for him with the system administrator permissions. And then he becomes a same system administration on that AWS accounts, right? But there's another technique that's called EIM set default policy version. That means that the attacker has the version v1 right now on his, and he has this privilege set default policy version. But to become a system administrator, he needs that the previous version or any of the previously versions has the system administrator possibility. So he has a precondition to privilege escalate in this technique. So how do we find out possibilities of privilege escalation? There is a tool. There's called Cloud Explaining, and was created by Kennedy McRae, was first released on 30 April of 2020. And this is an AAM security assessment tool. This tool is able to find out privilege escalation possibilities in customer policies, in line policies on AWS, and also find out about data filtration possibilities, resource exposure, credential exposure, and infrastructure modification. So this tool is really great. And if you didn't know, you can use it to find out possibilities of privilege escalations in your environment, right? So, any other what are requirements that an attacker would need to move laterally between AWS accounts would be ID of the related account. So it can be found in CloudTrail, IAM policies, and also Cint. And you can also, for example, Cint stuff, you can find out the company GitHub, find Terraform scripts, and other kind of things. And those numbers might be or might not be, but they are probably hard coded on those files, right? So, and this we have an example of CloudTrail, and we can find out there's account ID doing anything here with the account ID, and you can find out the account IDs also from the CloudTrail. So, if the attackers also use AWS organizations or control tower, the attacker also he needs to know a role to assume on these accounts. So he's in account A, he wants to assume a role in account B, but he wants to know a role. He has to know a name, the ID of the account, and he has to know the name of the role to assume. But if the organizations use AWS, if the AWS accounts use organizations or control tower, the attacker knows the name of those roles because they are hard coded. So if the attacker gets access to the master account, it's game over. It's final dance, because from the master, the attacker with the assume role condition can assume any role, can assume a role called organization account access role, or he can also assume a role called AWS control tower execution. And those roles, by default, they have admin privileges in all the accounts with the same organizations. So protect your master account as much as possible. If it's well, do not use any kind of workload on the master accounts. So there are some scenarios or best practice from AWS that we can explore to understand lateral movements possibilities. So the first scenario is called rub and spoke. This is a really well understood network design from AWS. So we have several accounts, accounts A, account B, account C, a shared services account. And what you can do, the wrong things that you can do is create a EC2 instance with two network interfaces on the shared services, and those interfaces connect to the account A to the account C. So it might be a route point. So an attacker who got an account A, he can hack this instance and then jump to account C. But you can also do a VPC peering between account A, account B, and account C. This also might break the network the interface that want to work on this network. So don't do it. Please don't do it. Right. And another AWS pattern and possible mistake that you can do is to cross account back to master or CI/CD accounts. So this we have a partner, a pattern that we have a user, and the user logins to the master account, and this user he has access to CI/CD, and he has also to dev and to stage, but he doesn't have access to prod, right? But what happens if the administrator of this account do a cross account between the dev and CI/CD? This user, as an attacker, he can just do a cross account to the master and just jump to the dev. He can also jump to the dev, but the CI/CD account, as he has permissions to deploy in prod, he can also make a jump to prod. So Also, do never cross accounts between your dev environments and stage environments back to a master or a CI/CD account. So in order to find out in our clients, we tested a lot of tools, but none of did what we wanted to do. We tested AWS PX, we tested Cloud Mapper from Duo Labs, we tested several tools, but none of them was able to deliver what we were thinking about, what we thought that would be a good delivery to find out lateral movements. So we have to create your own. So we had some requirements for that. One of our requirements is to use open source and free tools. Automatically download the necessary information from the AWS APIs. Plot an easy to understand graph with paths, what an attacker could do at the control plane and data plane as well, and has a carry language to allow alerts to be raised automatically. So as a backend, use Gremlin as a carry language. We also use Cloud Explaining to download all the information, not all the information, but some information automatically, and also understand what privilege escalation techniques would be useful. And we also use D3.js for visualization. So what we model things like if anything EC2 instance or a Lambda, anything from data plane is a square, anything from the control plane is a circle, anything that has, if it has in the same account, AWS account, it has the same color, different colors, different accounts. And we also model a lateral and arrow, and that's a directional relationship between any of those instances, right? So kind of demo time. Well, the name has no name. The tool has no name yet. So there was, back on the Cloud Village, there was a poll on Twitter to find out the name of this tool. We are in some days to release this tool, so keep looking for our Twitter accounts, and will be released soon. Right. So for the demo time. As I said, the tool has no name yet. And by clicking search, it downloads all the informations and plot on the graphs. And you can also zoom, you can pan in, pan out, move laterally things. As you can see, there are several colors here. And this data, it comes from a simulation that one of our clients who has hacked. So one of our clients lost his credentials for one of his accounts. And by the end of the time, the end of the day, the attacker just created a EC2 instance and running some crypto miners on that. So we were able to catch it pretty quickly and clean up their account. But what the attacker could do, if he has the visibility of the possibilities that he could do, is much more scary than just crypto mining. So just organize, you can move things, you can just organize things here. The thing is, the attacker lost control of this account, and he would be able to create a EC2 instance. This EC2 instance has a assume role, had an assume role. He would be able to jump to all other accounts because this EC2 instance was in a master account, and he also has a VPC peering. And if you watch closely, all the connections between VPCs are two-way connections. So you have EC2 instance. We have a connection from this EC2 instance to this EC2 instance and back and forth. And who could also jump from this to this EC2 instance and then also assume a role in this account here. As you can see, he could assume role in another accounts. You know, he could also jump to this EC2 instance right here and then become administrator on this orange account. One thing that we find out, the easiest way to analyze these things is to looking for big clusters like this, because they have the most interactions like this. And things like this are just lambdas with assumed roles, and they're not really well connected to the graph. So by analyzing, the easiest way is to looking for large clusters. And you can also have a filter here for privilege escalations that you could find out that this role here has a privilege escalation possibility to this role, that is administrator role, by creating a new policy versions, as you can see here, right? So you can also find out privilege escalation possibilities. So what's the future or our to-do list for this tool? We want to evaluate all the restrictions of all privilege escalation techniques, so it will take a little bit more time. We also want to add support for other resources like S3 and RDS, and also support for resource-based policies, and a little bit better visualization and filtering, because there's what this visualization things was just a POC, a POC, and was using another open source tool. It's called GraphXL or something like this. But you want to do better with this. So in order to conclude, what you have to have in mind. So also try to apply the least privilege to IAM role permissions. And this is said and done, we know that. But you can use SCPs and IAM boundaries. And please try to never use a resource star. That brings a lot of possibilities to attackers. And don't run any workloads in your master account. So if you run any workloads in a master account, and if you by accident give this workload EC2 instance assume role, he could jump between all those accounts in your environment. And also don't cross account any account to master or any account to CI/CD accounts and things like that. So always review all your trusted cross account policies and segment your network and accounts as much as possible. So thank you guys. Thank you for coming, watching my talk. Hope to see you guys next year on Cloud Village and DEFCON 31. See you. Oh, so these are my contacts, Twitter, the TT Security Twitter, and my LinkedIn. So if you have any questions, just keep in touch. See you.